Chapter 1, Windows Fundamentals and Architecture, teaches you the basic and fundamentals of Windows operating systems. As I mentioned in the introduction, the reason that you need to know the fundamentals of Windows operating system is because you're designing a Windows operating system application. So in order to interact with operating system, be able to read the messages, send messages to the Windows, and interact with other applications, you have to know exactly, number one, how Windows gets operated, and number two, how they're interacting with the main operating system. So in this section, we are going to discuss the following outlines. The objective of this specific chapter is to define processes, threads, and multitasking. But of course, we are just talking about in an overview basis. In other words, we don't get into the detail. I'm not going to show you how to create a thread right at the moment. There are other courses, there are other sections of this class that discusses it a little bit. But here, it's just an overview of what we are going to discuss about the terminologies. Also, we talk about the structure of the memory management. You have to be familiar with that, specifically if you're coming from an area that has not worked with Windows environment. Explain the purpose of messages and the concept of event-driven. As I explained in the introduction, we have a chapter 6, that talks about messages in general. This is only a purpose of a message, not necessarily discussing the whole thing. We have a separate chapter for that, and I will take my time on that section, discussing different messages. And finally, describe the minimum component of a simple Windows-based application. Not to mention that the process of Windows generation and creation of a window will be also explained throughout the entire chapter. So let's get started with the following concept. I'd like to explain the concept of process, virtual system, threads, and multitasking. And then, of course, we get into threads, messages, and message queues, and finally, event-driven programming. Let's start with the process. Well, the concept of a process, basically, many people think that a process or an application are the same. Many people in today's business, they think, oh, run that process for me, or run this application for me. As far as Microsoft is concerned, there are two different things. An application consists of different programs, if you think about it. And each program is just a sequence of some instructions. And each instruction, it does something for you. Now, if you go back a little bit, what would you do with an application? You install an application. Basically, an application consists of files, DLLs, bitmaps, resources. Perhaps you register some of them, and then you go from there. But by the time you're running the application, you double click on a particular shortcut, and then you launch that application into the memory and you start working with it. Let's bring an example in here. Right now, if I go and select out of my programs, select perhaps Internet Explorer, this is an application, right? I run this application, and of course, it launches the Internet Explorer. I'd like to show you a small little program in here, part of operating system, by right-clicking on the taskbar. They call it what? Task Manager. If I launch that, as you see, besides showing the performance, available memory, and so forth, we have an application. I'm running 3 different applications at the moment, right? However, if I click on the processes and sort the processes with a specific name, as you see, the iExplorer process is also indicating that that application is running. Now, sometimes one application might have one or more processes related to. As you see, I have a lot more processes than I have application in here, don't I? Not necessarily every single process is related to a window application. Some of these processes might be service related. So some of these services, as you see in here, not necessarily are related to an application. Some of these services, such as perhaps iNet Info, is related to a specific service that hosts websites. You might be familiar with it. They call it Internet Information Server, or IIS. iNet Info is responsible for that. I don't want to get into the detail of these processes that you see at the moment. Just wanted to show you that by terminating a process, ending the process automatically gets rid of the application for you. I do not recommend you to do that. sometimes some of these processes might cause problems for some application. You're not supposed to just terminate it like that. I just wanted to show you for demonstration purposes. But let's get into the detail again. What is a process? A process, usually from MFC developer point of view, is an instance of a running application. Sometimes your application has one, sometimes has more than one processes. But basically, a process consists of the following. Number one, an executable program that you can execute it, and that executable program not necessarily is an exe file. It could be a DLL. It could be a DLL or a library that can be loaded into the memory of another exe application. So it's just an executable. That means you can execute it. However, some of these DLLs that I'm talking about, they are not necessarily having their own process. They might be part of another process. So if you want to just associate a running process, that has to be an exe. That has to be launched separately. And usually this process might launch other processes into its own memory space, which are DLLs, which are outside of the scope of this class. You have to take courses like 1011 or 1304 in order to get more familiar with out process and in process environment. So basically a process consists of an executable program, a private address space in memory, and when we talk about that, we have to explain the entire architecture of the memory, which is coming up in a minute. But consider this. Would you accept two applications running side by side, and by failing one application, your application would fail also? If you remember, we had that scenario in Windows 3.0 and 3.1. Everything was fine and dandy, and one application was failing. Nothing was working, even operating system. So that was a problem, if you remember. For that problem, Microsoft has come and they have actually separated every single application into its own virtual address space. They say if you fail, it's not going to affect anything else. In other words, instead of having application to directly access the hardware, they say you cannot access the hardware whatsoever. Operating system creates a virtual machine for you, and they say, okay, you want to access hard drive, you want to access memory, you want to write to the screen, you can, no problem. But in reality, you don't. You're writing to the subsystem, and then kernel of the operating system really takes the job and does the work for you. So basically, a private address space, when we talk about that, within the memory, we have an address space per application. Usually is a 4 GB address spacing. And when we talk about address space, we're talking virtual address space. Because as you know, your computer might have only 128 megabytes of RAM or more, I don't know. But we give your application 4 GB of virtual address space. And perhaps you say, how is it possible? There are just address space. In other words, there are just 2 to the power of 32 addresses available to your specific application, and then those addresses gets mapped into the physical memory, and then basically you don't have to be worried about having a linear address space to be available inside of the physical memory, which I have a video in which you really see the whole thing. Then you need some system resources such as files. Everybody is familiar with the concept of a file. You can save your information into a file, you can open an IO and read it. Or pipes, there are communication channels between two different nodes. And basically that's the old story that I'm going to get into it in a minute. But usually what is a pipe? Consider it like a water pipe or plumbing pipe that connects two different nodes to each other. So application can use the pipe in order to send messages. Now consider that pipes are two different kinds, one way or two ways. In other words, you can only send or you can send and receive. And we have a variety of different pipes, type. In other words, you have name pipes. You have perhaps heard about it. Still Microsoft uses it, specifically SQL Server product, uses name pipes frequently, or other sorts of pipes that you can actually write. Most backup utilities are using pipes. They're actually creating a pipe on your machine and start communicating via these pipes over the network perhaps. And then we have communication ports. That's the origin for Windows sockets. that, sharing the same IP address over the network perhaps, and running multiple applications at the same time. And then of course semaphores. There are flags that you set for your resource in order to be shared among multiple threads at the same time. Consider you have a variable of type integer, and then two threads are working with this specific x value. One thread increments it, one thread decrements it, and they're both running at the same time. You can't really understand what would be the end result, would you? You have to somehow lock it and then have one thread to finish its work, and then the second thread come and work with it. In other words, you want to make sure that you do synchronization between two different threads. So semaphore is a specific methodology in order to make sure that your resources are protected. So process basically obtain all this information, and of course you need to have a worker thread. What is the thread anyways? Thread is the smallest unit of execution. In other words, for every when I'm talking right now, for every single word that I'm saying, basically I'm using a thread. In other words, my process communicating to you, explaining course 1011, that's the process, and every single word that I'm using for this process would be a thread, as an analogy, if you could understand that. Or the process of walking, I'm walking. Every single step that I'm taking is a thread. If you understand, CPU can only do one task at a time. No matter how many applications you're running, no matter how powerful of a CPU you have, only one task can be executed at one single time. So imagine how many applications are running. Imagine each application sends numerous number of messages to the CPU, but only one of them can be executed at one time. So that's why you have the high frequency power on your Pentium, perhaps Pentium 3, Pentium 4, and so forth. Depends on their speed. You're actually breaking down 1 second into a smaller time slice, and then every single thread can get one time slice. Now, the more threads you have, the quicker you finish. However, having more than one thread not necessarily is a good idea all the time, because you might damage other applications' performance. So you have to understand how to go about, working with the threads. Not having multiple threads is a good design decision. So keep that in mind.